Okay, math 3. So let me go through this, how I did this with you guys, and hopefully it will help. The first thing I just want to do is I want to make some measurements. Now, I noticed a lot of you measured in inches, and I am not going to measure in inches. I'm going to measure in centimeters. Centimeters are just easier to work with. So I'm going to measure this length, and my eyes aren't that great, but I'm going to say that's about 8.8 centimeters. Write that down. So the length of the boat on the paper is 8.8 centimeters. Let me measure the height of the mast. Now, if you look at it, it's darn near the same. It's like, we'll call it 9. We'll call it 9 centimeters on the paper. So that's an interesting thing to notice about this boat, that the length of the mast is actually longer than the boat is. Okay, that's a really good sign this is a racing boat. Okay. Then I want to measure the length of the yard arm, and I'm pretty sure that's called the yard arm, but I am not a sailor, so you guys can check me. And this looks like, we'll call that 4.7. Let's call that 4.7. So the length of this yard arm is 4.7 centimeters, sorry. And it's really good to label this up so people know what you're working on. Okay. Now, we know in real life that the length of the boat is 130 feet. So I'm going to use these facts to help me figure out the real length of the yard arm and the real length of the mast height. And I'm going to change pieces of paper here just so I have some more work room and I can write a little bigger for you guys to be able to see. Okay, so let's put this aside here for a second. See if I got that lined up good enough for you. Looks maybe that'll be okay. Yeah. Okay. All right. So let's do the mast height first. Okay. So what do I know? All right. So I know that in my model, and I'm going to compare that to my real life. In my model, I know that the 8.8 centimeters was how long the boat is on the drawing, and that's 130 feet in real life. All right. Well, I want to figure out how long 1 centimeter is, and then I can use that to figure out everything else, finding the unit rate. I don't really want to work with decimals since I don't have a calculator, so I'm going to change these out of decimals. So I know that 8.8 centimeters to 130 feet would be the same as 88 centimeters to 1,300 feet. Okay, now I'm gonna have to do some long division here. One of my least favorite things to do, but I'm gonna have to do it. Okay, so I have to divide because I want to figure out what 1 centimeter is going to be. Well, I know I'm going to have to divide by 88 because 88 divided by 88 is 1. So I'm going to have to divide by 88. All right, so I have to have 1,300. Now I'm going to do this the way you guys have seen me do this a lot. 88. This is the way they do it in a lot of other parts of the world. And boy, let's just see. Let's go 10 because I know that's 880. 10s are my friends. And if I do that subtraction, I think I get 420 because 20 more would make 900. And then 400, yeah, so 420. Oh, almost 5. Not quite 5. Is that right? Could I get 5 out of this? Well, half of this would be 440. So yeah, I can't get 5. I can't get 5. Okay, so we can get 4. I could go 2 if I wanted to, but let's just go 4. Okay, so that's 4 times 80 is 320 and 32. So 352. 320 and 32, 352. Okay, well, let's see here. If I went up to, so that's going to be 48 to get me to 400 and another 20, so 68. Oh, so that's it. This is going to be my remainder. So I'm going to have 14 and 68 over 88. We're working approximately here, so that's about 14 and 6/8. So that's about 14 and 3/4. So what that's going to tell me is that 1 centimeter in my model is about 14 and 3/4 feet long. So 1 centimeter in your model is 14 and 3/4 feet in real life. All right. So can I figure out the mast length? Well, yeah, sure. Well, I know that the mast length is, I can extend my ratio table up here. I know my mast length, I measured it, was 9 centimeters. So I'm going to have to multiply this by 9. So I have to multiply 14 and 3/4 by 9. Okay, so 14 times 9. Let's see what I can do down here. 14 and 3/4 times 9. That's 14 times 9 plus 3/4 of 9. 90 and 36, 126. Plus 3/4 of 9. All right, well, 1/4 of 9 would be 9/4. So 3/4 is 27/4. And if you want to change that, so it's 126. Not quite, let's see here, 7 would be 28, so 6 plus 6 and 3/4. So the mast in the real ship is about 132 feet and 3/4. Okay, that's not 132 feet 3/4 inches. It's 132 and 3/4 feet. And we were saying before that the mast was actually longer than the length of the boat or the ship, and that's what we got in our calculation. It's always good to check. All right, so let's figure out what the approximate length of the yard arm is in feet. Well, we measured the yard arm is 4.7 centimeters. So I know I'm going to have to multiply 14 and 3/4 by 4.7. Okay, sorry if I'm getting this a little out of the range. I think I'm going to have to, let me see here if I can fit this somehow. I think I might have to use another piece of paper. Sorry about that. So we're going to have to do 14 and 3/4 times 4.7. And the reason is because, hey, 1 centimeter has to go up to 4.7. So I have to multiply that by 4.7. And I have to multiply this by 4.7 as well, just a ratio table. So we're going to have 14 and 3/4 times 4.7. All right, 14 and 3/4. 4 7/10. Not super pretty, not super fun to do this. Let's see. You know, we could use maybe a generic rectangle model for this is going to be the way to go. So I know that this is going to be, I'll represent this as 14 over here. I'll represent this as 3/4 over here. And I'll represent this is my 4 inches and this is my 7/10. 4 times 14 is 40 and 16, so that's 56. This is 12 over 4, which is just a good old 3. That's nice. 7/10 of 14, so that's 70 and 28. That's 98/10. If you want to do 98/10, it's 9.8. Want to go there. This is 21. Sorry. A little crowded in there. 21 over 40. Not super pretty. Okay. Kind of at this point, you're kind of going, I'm estimating, so we could estimate a little bit here and make this and round these things up, or we could just keep them the way they are and calculate this out a little bit. Let's see here, 56, 59, 68, 68.8 plus 21/40ths. Well, you know, 21/40ths, that's awfully close to a half. We're just going to call this one half. And as you guys, sorry, writing's a little small. As you guys know, that's 0.5. So if we wanted to add these guys together, so that is 69.3. So back to our ratio table. If the model was 4.7 centimeters, then in real life it's 69.3 feet. Let's take a look back here at this. Does that look right? Does this look like 69 point? Yeah, it does, because it's the length of this yard arm is more than half of the boat. Half of the boat would be 65, so 69 totally makes sense. Okay, so my work so far for this, what do we have? The length of my mast was 132 and 3/4 feet. The length of my yard arm was 69.3 feet. 69 and 3/10, if we want to stay in fractions, feet. Okay, now in inches, well, 69 and 3/10 feet, every foot is 12 inches, so I'm just going to have to, I'm not going to do the multiplication out right now, but I need 69 and 3/10 times 12. And that's going to give me how much it is, 2 inches. All right. Now, what's the scale factor? What's the scale factor going from the model to real life? Okay, from the model to real life. Now that's a little bit complicated. Let's see if, let me put this on pause for a moment and come back with that.